Welcome to our first video about Chapter 2, Consumers in the Marketplace, and the first video talks about demand. So demand, we see here the title slide of the presentation, Chapter 2, Consumers in the Marketplace, Background to Demand. So consumers, people who need something, are willing to buy something, are actually going to buy something. At the end, we talk about us. We talk about people, we often call it households, that make decisions, that make the buying decisions or the decision to demand something at a specific price. On markets, in economics we talk a lot about markets, and that can be different things. That can be supermarkets that we typically use. It might be little shops. It might be farmers market outside where you get all the fresh things. It might as well be virtual places. It might be online platforms, whatever places, real or virtual, where we buy and sell goods, services included, and so on. So now we have an idea what markets are. And I suppose that most of us know the typical market diagram, have seen the typical market diagram with an upward sloping quantity supplied and downward sloping quantity demanded, or just demand function, supply function, which intersect in the middle in a place that we call equilibrium. You can see here figure 4.1, that's the first figure from chapter 4. So we come back to this later when we talk about chapter 4. And today we focus on the first half, quantity demanded, the demand function, the demand decision of people. How do we decide whether we want to buy something and how much of this good? You can see here that this part of this video is a part of chapter 2, focuses on the first 3 subchapters. What is the best price? Introducing the demand curve. That will be sort of in the center. What is the demand function or demand curve? And the factors influencing demand. And trying to imagine how that looks like. Let's say we want to buy something, you want to buy something. Let's say apples. So we see different places, different possibilities. We have the supermarket that we can enter here. We have the farmer's market, the stands full of offers. That's one possibility we might keep in mind here. We might want to imagine at that point. So how do we in economic theory approach that topic, the topic of the demand function, which is again here figure 2.1, so this downward sloping line, downward sloping function, that's what we want to talk about in this chapter. The chapter approaches as learning outcomes, first of all, the demand function or demand curves, the different factors influencing the determinants of demand, factors leading to a change in demand. Yeah, full stop. These are basically the 2 things we focus on in this video, and then the next video will be about price elasticity. Learning outcomes are based on the question, what is the best price, or what is sort of the problem of businesses? In order to do so or to describe this, we have to talk about the objective of firms. What is it that firms want to achieve? And the typical assumption that we make is they want to maximize the amount of profit. That's the typical task of a firm. If you run a firm as a manager, if you work in the management of the firm, one thing that you want to achieve is maximizing the profit. There might be others like the revenue, the market shares, and so on. At the end, the best price, the price that brings people to buy exactly the amount of the specific good that people want to buy, this best price typically helps the firm to meet this chosen objective. So let's keep this basic assumption with us when we go to our board and talk about a demand function that basically describes the relation between price and quantity demanded, but also other things, other determinants of demand. Let's enter our board and say, okay, this is our one roadmap that we follow. We would like to talk about profit maximization and how this can be done, how can this be achieved by bringing the people to buying the goods and to buying the right amount of these goods. So what we want to know is, how is the quantity that people buy, the quantity demanded, determined? What are the factors that make us buy a specific good and make us buy a specific amount of these goods? I suppose most of us would agree that the most important factor that influences us buying something is the price of a good. So when we look at this picture I made sort of on my way to work, a stand selling different fruits, vegetables, and you can see here the current offer of specific type of apple, of L-star in this case, to a specific price. And that's what we would like to model now, would like to say, okay, what are these influencing factors? One influencing factor will be, or is definitely, the price, or in fact, different prices. The price of the good itself is one important, but is that everything? Or are there also other prices? And are there different other influencing factors that make us buy more or less of a specific product? I'd like to invite you to take a minute in order to think about this before we continue with this video. It will be different, the things that you found, but you might have taken into account that besides the price of the good itself, there is something like your budget or your income. The budget in the sense, there is your income that you spend for different things, for your rent that you spend for transportation and so on. And a part of the income goes into your budget for this good, for food, for apples in this case. It also has to do with your preferences, as we call it. And these preferences are described in economics with something that we call utility. What does it bring me to buy apples, to consume apples? Do I feel better afterwards? Obviously, otherwise I wouldn't spend money on this. And then there was this that we said prices, several prices. So the price of the good itself is one. You might have thought about, okay, there are typically goods that we either buy instead of apples. If apples are relatively expensive, we might get bananas, oranges, whatever. This is something that we call substitutes or substitute goods, alternatives at the end, things that we buy instead of apples that we can substitute apples with. And prices of complements is the other concept. These are things that we typically buy together with whatever. If I'd like to have cheese with my apples, then I buy these two together, and if cheese is more expensive, I might say, no, I don't buy apples, I get some bread today or whatever. And I hope you found different things that influence our demand for apples, or your demand for apples, which might be whatever. influencers, telling you perhaps an apple a day keeps the doctor away. The news, external information, it will of course be something like marketing, advertising, product placement, the price, the promotion, and so on. It might even be the weather, ... whatever came to your mind as factors that influence the quantity demanded. Then this is influenced by the prices. The price of that good, prices of substitutes, prices of complements, and so on. It's also influenced by your income or your budget that we typically abbreviate with a Y. The utility is abbreviated by U. And for the others, we don't necessarily do abbreviations, but arguments that we brought forward here is something that we call a demand function. We often write that the quantity is determined by this in a mathematical way, saying so the quantity demanded is a function of the different prices, the income, and so on. So it looks like a mathematical function is f of, a function of, but of course this is a bit inconvenient. That's why, as in several more formal approaches, we typically abbreviate. And this is something that we could call the complete demand function, as it describes all factors, or not all factors, but has these ... here, is open to other possibilities that we personally find are important here. And that's good that we have sort of this full function, but in order to analyze a demand function, and you might recall the picture that we saw at the beginning, this downward sloping function, quantity demanded as a function of the price, we need to only take a part of this. And the typical part that we look at is quantity demanded as a function of price. So these first elements of our function. This first part we call the endogenous variables, quantity and price, as compared to the others that we call exogenous determinants of variables. So what we do is we take this part, and we call this also a partial analysis. Quantity demanded is a function of the price, CP. CP is an abbreviation, perhaps someone of you knows, of the Latin term ceteris paribus. If you're not familiar with that term, have a look in our book. You find it there, or just search whatever you find about the concept of ceteris paribus. It's a partial analysis that makes it possible for us to now apply the typical demand function. So putting this up here, quantity demanded as a function of the price in a graph. Let's make this a bit bigger so that we can see more. And in fact, we already saw that this is typically a negative relation, that it's something like this. Quantity demanded as a function of price. The fact that it's a negative slope of this function results from sort of our behavior, that we tend to buy more of those goods that are cheaper and less if the price is higher. We call this the law of demand. And this law of demand is described also in our book, of course, and in our presentation. Let's have a quick look there. Slide number 10 in our presentation. The law of demand states that ceteris paribus, as the price of a product falls, more will be demanded. If the exogenous variables do not change, there normally is a negative relationship between price and the quantity demanded. I hope that this law does make sense to most of us, and it's the sort of real relation that we have here. In fact, when we do our model, we often do or use a linear function, a straight line that goes down there, because it's easier to analyze. So let us do the same diagram, but this time let's specify some units, as well as a straight line, a straight combination. So you see that I put the prices from 1 to 5, euro, pound, whatever you want, and let's say the demand is something between 20 and 100 units. A quantity demanded, a straight line combining the 5 on the price axis with the 100 on the quantity axis. And now, we need a little bit of math. How is such a function described? Where does it start, and what is the slope? Mathematically, this function, this linear function, is quantity demanded is A plus B times P, where A is the intercept, is the point where the function starts, where it intersects the axis of the dependent variable, which is in this case Q, the quantity, depends on P. And B is what we call the slope. The slope we typically illustrate and compute via this little triangle, which in English is called the rise over the run, so the change in quantity divided by the change in price. If I change the price from, let's say, 4 to 3, then the quantity demanded is going to increase. The change in price is -1. And you see that little triangle that I make in front of the P, it's a delta, a Greek letter delta, and it says the difference, the change that we do. And the change in price is -1, whereas the change in quantity is positive. It goes from 20 to 40. Because basically what we have here, as we said, Q, the quantity, is the dependent variable. We could also add here Q as a function of P. If there is a price of 3, then from this 3 we go to the graph, to that point, and then down there, in order to say, okay, if the price is 3, then the quantity demanded will be 40, as the quantity demanded is determined by the price. So in our case, the starting point, the A, the intercept as we called it, is where the function starts on the Q-axis. That's in fact our 100. Whereas the slope is the rise over the run, the change in quantity over the change in price. So our B, the slope is the one change over the other, so 20 over -1. The slope B is -20, which gives us our first function here, which is quantity demanded is 100 minus 20 times P. So at this point, I know that some of you might say, oh dear, why is he talking so long about this? This is a normal, simple mathematical thing. And others are a bit confused because the math classes are quite a time ago and need some time to adapt here. I recommend that you do this. We look at 2 more aspects here. In our book, there is an appendix to chapter 2 that also again introduces these concepts of the slope and so on, so that you are able to review these things. But 2 excursus here. Number 1, if you recall your school math, then typically the graph was the other way around. The axes were the other way around. Look basically like this. You had y is a function of x. So that would be the situation in a math class. You see that the axes are the other way around. Here you have, and that's what we often use to, the dependent variable, the y that depends on x, on the vertical axis, whereas in our economic models, we have them on the horizontal axis. I'm sorry for this, and in chapter 4 we will also learn why this is the case, but at the moment we have to get used to this. Also in maths, A would be here. A on the vertical axis, and that's where the function would start, and you had the same rise over the run, the same slope triangle. Also in math, you might have the way to write this down, saying that y is mx plus b, which is sort of just another way of writing this, but it's also confusing because in our class here, we don't say mx plus b, but we use the b times, and not x, but p plus a, and then we put the a to the front, a plus b times x. The second thing that we look at is the function that we have been discussing, quantity demanded is a plus b times p, but with our law of demand, where we said basically we know it's negative, why don't we just write it's a minus b times p? So this is mathematically correct. The other one is easier and also used by our book. Nevertheless, we are going to stick to the correct version and will describe our function as a plus b times p, and then find out, law of demand, that in fact the b is negative. Let's take this as some background information that you might or might not want to use. I put it a bit further down on our board. Yeah, rearranging, you saw that I highlighted our demand function, quantity demanded, a plus b times p, and noted the intercept on the one situation and the slope b as the other parameter of our function. And what we did, we showed our functions, we illustrated our functions, the relation between supply and demand, already in two ways. We did it in a graph, and the graphical demand function that is downward sloping, and we did an equation. And in fact, we have three ways. Besides these two, we could also say, let us talk about this relation, that for 4, I can go here and then the demand is 20. For 1, I can go here and then the demand is 80, and so on. And put this in a value table where we have the values of the dependent and independent variables. So put the dependent variable, for example, to the left, the price, which can take the values that we see here, 0, 1, 2, 3, 4, and 5. Then the graph ends. And the respective values of Q, which are a function of P, which depend on P. And we can see if the price is 5, then in fact nobody is going to buy anything, then the demand is 0. If the price is 4, then we can go here and down there, and we see for a price of 4, the demand is 20. 20, 40, 60, 80, and 100. That's the relation between if the price is 0, then there is a demand of 100. Which also sort of brings us to some limitation of our model, of the way to show this in a linear relation. Of course, in reality, there is no such a thing as a price of 0 where then people buy something, but it's more realistic to have a demand function that sort of goes like this. When there's a high price, there's not a lot of demand, and if the price goes down, 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 you see that demand increases, and it's normally not going to be at a 0 somewhere here, but it goes in this direction and is normally only at a very low price. If everybody sort of has what she or he wants, then it might hit the 0. But otherwise, the upper graph here in red is the more realistic one, or if we take the blue one, but it would be complicated in a mathematical way to describe the slope, for example. The slope b in case of a nonlinear function would be more complicated, and that's why in our model we typically stay to this. So that was our first analysis, and let us write down there are these three ways of showing our demand function. Here we have our first bit of theory, this first frame in which we describe how we in economics model the demand function. The next step will be to ask ourselves what happens if variables change, especially in this ceteris paribus. We basically said the others don't change, but if they change. Let's go ahead and think about our variables. We have the endogenous and the exogenous variables, and still sort of the mystery to solve what is ceteris paribus about. This will be something we discuss in class, but we also might ask ourselves, endogenous, exogenous, what is that? What changes if one of these variables changes? And in fact, that's the big difference that we make here. To describe this, we typically differentiate between the exogenous and the endogenous variables. So number one, what happens if an endogenous variable changes? And I just took the graph and the example that we just had from the left-hand side, copied it there. What happens if an endogenous variable changes? And an endogenous variable basically here can only be the price, because the price is the determinant. The price determines the quantity that the consumers that we demand. Price change, let's say it changes from 3 to 2. Now our model works that way that we start at a point saying with a price of 3, what is the quantity demanded? Our price P1 is 3, and from the 3 we go to the line, and then we go down as sketched here in the graph. So what happens if this price changes? It's no longer 3, but it's 2. P2 equal 2, and we have to do the same. We have to go from the 2 to the demand function and then down to the quantity demanded. If we do so, we come to a quantity of 60. So at the end, what we do, we observe a change along the curve from the one point to the other point. If an exogenous variable changes, and now we have different possibilities. We saw that the exogenous variables are, for example, the income, might be the tastes, might be external influences, might be the prices of other goods or substitutes, and so on. So let's say income goes up as one example. If we now think about what happens here if the income goes up, exogenous at the end means it's not directly in the model. It's not found on the axis, and that's why we cannot see the change directly on this demand function. But the point is that the demand function itself is going to change. The result of this income increasing would be a shift of the demand curve, in this case to the right, because if the income increases, people are typically going to buy more. And in our situation that we had before, for a price of 3, the demand is 40. Now at the same price of 3, people would buy more. In this case, something like nearly double, 80. And we see that there is this change from quantity 1 to quantity 2 because the whole curve shifted. So that was quite some input. You can follow this input, of course, in the book. You can ask questions in class. That's what the videos are for, to prepare, and then you sit down and write down questions. And you can, of course, follow our presentation. Let us have a quick view there. We came from this definition of the law of demand. We also have a definition of the exogenous factors, price of substitutes and complements, the income, tastes and preferences, and there might be more. One example are price expectations, and they are numbered here 1, 2, 3, 4. So that's also where the 1, 2, 3, 4 here comes from. If the exogenous variables 1, 2, 3, 4 do not change, ceteris paribus, then there is a negative relation between price and the quantity demanded. Also the relations here, movement of the demand curve, there might be a movement to the left, there might be a movement to the right. You find it in the book at figure 3.2, and more explanation about this, of course. You find the text there in order to be able to prepare to work on this. But I'd like to invite you as well to prepare our class by looking at a function, another function. Let's call this homework or whatever. Take the function quantity demanded is 1000 minus 50p. Produce the graph, the value table, and draw the function. Secondly, let's say now there is a change in an exogenous variable that results in our function to change to quantity demanded is 500 minus 50p. As you already have the function, the equation, the two other things are draw the graph and make the value table. With this little task, we end this video, which, as you know, is a preparation for our meeting in class. So when we meet in the next session, please be prepared in the sense, if you have questions, have them prepared and ask the questions. And then secondly, we are going to sort of check what are the results here. We are not going to do this homework together, as I think everyone can do this when she or he takes the time and goes step by step. But we check, did you get the same result as is expected here? Okay, so much for the first video. See you in between in class and then in the next video.